we will discuss hydrogen spectrum or line spectrum of hydrogen. What it means? When electric discharge is passed through hydrogen gas, the gas molecules, hydrogen molecules, get dissociated into energetically excited hydrogen atoms. These hydrogen atoms, which are energetically excited, they emit electromagnetic radiations of discrete frequencies in different frequencies. When these electromagnetic radiations are resolved in spectroscope, what we see a series of lines. So these series of lines, they constitute hydrogen spectrum or line spectrum of hydrogen. First of all, Balmer on the basis of his observations, experimental observations, said that if these lines are spectral lines are expressed in terms of wave number, then the visible lines in the spectrum, they obey the formula. This is wave number is equal to 109677 into 1 upon 2 square minus 1 upon n square. What is here this n? This n is greater than or equal to 3. So this series of lines which obey this formula, they are known after him as Balmer series. All these separate lines, they fall in the visible region, After that, Rydberg noted that, J. Rydberg came and he noted that all series of lines, जो भी lines हाइड्रोजन स्पेक्ट्रम में है, उनको हम इस फार्मूला से डिस्क्राइब कर सकते हैं, सारे लाइन्स को, इंक्लूडिंग दीज लाइन्स इन द Balmer series. That is, wave number is equal to 109677 into 1 upon n1 square minus 1 upon n2 square centimeter inverse. So while n1 is 1, 2, 3, n2 is, it can take values n1 plus 1 or n1 plus 2 or n1 plus 3 or n1 plus 4 and so on. While this 109677 is known as Rydberg constant. First five series of lines corresponding to n is equal to 1. When n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So we get first five series of lines. These series of lines are named after their discoverers as Lyman series, Balmer series, Poston series, Brackett series and Pugh-Fund series. So these are five series of lines. So in Lyman series, n is equal to 1. So n2 is equal to 2, 3, 4, so on. In this series, n is equal to 2. n2 is equal to 3, 4, 5, 6, so on. So यहाँ Poston में n is equal to 3, n2 is equal to 4, 5, 6, 7, so on. So bracket में n is equal to 4, n2 is equal to 5, 6, 7, 8, so on. So Pugh-Fund में n is equal to 5, so n2 is equal to 6, 7, 8, 9, so on. So these are five series of lines named after their discoverers. Now I will show the diagram which will give you the transitions, how these lines appear in the spectrum. So we will show the electronic transitions from one level to another level. I will show some series. I will show here like this. For this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, so on. So I will, if the electron jump from higher levels to level number 1, that means level number 5 say, level number 4 say, level number 3 say, level number 2 say, to the level number 1, these are transitions. So these are electronic transitions हम show करते हैं. So a line will get appeared in the spectrum. This group is called a Lyman series है. This is Lyman series. ये फॉल होता है यूवी रीजन में. इनकी फ्रीक्वेंसी फॉल होती है यूवी रीजन में, वेवलेंथ होती है फॉल यूवी रीजन में. Exactly when the electron jump from higher levels to level number 2, we get a series. This is called Balmer series. So this Balmer series fall in the visible region. ये visible में आता है. यानी इनकी जो wavelength है, frequency, they fall in the visible region. So हम निकाल सकते हैं इनका हम निकाल सकते हैं wavelength by using this formula. So if the electron jump from higher levels to level number 3, like this, so we'll get Paschen series. This is Paschen series. Exactly, if the liners jump from higher levels to level number 4 and so on, so we'll get bracket series and Puffin series. And if the electrons jump from higher levels to level number 5, so we'll get Puffin series. All these three series, Paschen, bracket and Puffin, they fall in the infrared region. ये सब आते हैं infrared में. ये तीन आते हैं infrared में. Infrared region में आते हैं ये. That means their frequency or wavelength falls in the infrared region. So this was about hydrogen spectrum. So we can say, in short, we can say that hydrogen spectrum contains a series of liners. The important 5 series of liners corresponding to n is equal to 1, 2, 3, 4 and 5. They are Lyman series, Balmer series, Paschen series, bracket series and Puffin series. So we can calculate the wavelength of these spectral liners by using this Rydberg formula. So this was about hydrogen spectrum. How these lines appear in the spectrum? This is because of the electronic transitions. Because atoms get excited. When atoms get excited, the electrons get excited. Electrons, when they are excited, that means they try to come to the stable energy levels, energy status. So they jump from higher levels to lower levels. So when they jump from higher levels to lower level, so they emit a radiation which appears as a line in the spectroscope or spectrograph. Okay, thanks.